Hi everyone, this is Rubin. I'm here with a couple of my colleagues, and we're just going to be walking you through what we've done for our project. All right, so let's get started. So to start things off, I just want to give you an overview of what we've done for our project. Our goal for this was to develop a couple of models that tackled the major problem of duplicate questions in question and answer forums. Specifically, we were actually looking at Stack Overflow. And our goal was to identify and create two models. The first model was designed to see if two questions, both provided by the user, are duplicates of each other. Our second model is meant to take a single user input question and search the entire Stack Overflow data set and see if there's anything similar that already exists that could potentially answer the question faster. So those are basically the two main goals of our project, and those are what we strive to accomplish. All right, now that we have that overview, I'm going to give you a quick glimpse into what does our data look like. So we acquired our data from a Stack Exchange dump that we found online, and we had to do a lot of work to fetch, clean, and analyze the data and see what we needed to have to answer the questions we wanted to answer. So over here, you can see the four main tables that we used: post, post links, tags, and users. And those are just some of the important columns that we used. Please be aware that there are several more columns associated with each table, but they weren't necessarily super useful to us in the evaluation and analysis process. All right, so a quick walkthrough of the overflow and what we've done as we built the model out and explained all our findings. So once we have had the data, we've used PySpark to clean, sort, and prepare the data for processing. Then we've used things like Plotly and Tableau to visualize the data and kind of understand the trends and see what's happening before we start working with it. The next step was to clean the data using tools like Spacey and prepare it for really doing hardcore NLP modeling on it. That next step, that NLP modeling, involves things using Esper, Universal Sentence Encoder, and the goal of all these things was to basically engineer the fundamental features that are in the data that can help us distinguish duplicates and questions that are not duplicated. All that information now is passed to our two models. The first uses a neural network in PyTorch, and that is meant to just simply identify if two questions are duplicates or not. The other one revolves around Weaviate, which is meant to search through the Stack Overflow database and identify if there's any similar questions available. Now, all this information, all this work, we've tied together into a front end that we built using a Docker and hosted using AWS. We've used Streamlit in the process to show and visualize all this information. All right. So before I hand it off to my lovely colleagues, I just want to give you a brief idea of what we've done for the analysis and the visualization. So you can have a quick look here. We've talked a bit about the questions that are part of the set, the tags that are used. We've done some time series analysis, and basically we've looked at how the data and the questions are distributed around the globe. So let's make it a little bit more real by actually showing you what it looks like. All right, perfect. So the front end here, you can have a quick look at what we've done here. This is actually part of our machine learning model, but I want to transition over to the dashboard where we're going to visualize the data that we've seen. All right. So you can see over here, we have a brief look into how the data set is distributed amongst the duplicate questions and the total number of questions, the tags, and the users that have contributed to our enormous data set. We have a brief overview of the top questions based on the different tags that are available. And we've also done some time series analysis down here, and to see how long it takes for users to mark a question as a duplicate. We've also looked at the distribution of duplicate and non-duplicated questions between different tags. And finally, down here, we've looked at the geographical distribution of the different questions around the globe. Now, one last thing, I just want to show you a quick glimpse into some of the Tableau visualization that we've done. So over here, you can see how we've compiled all this information, all the tags, into these word clouds to show which ones are most popular and which ones are popping up most often. This gives us an idea of what's in demand, what's being used, and what users are looking to have answered.
Hey guys, I'm Dilip. I'll quickly go over the two models which we have trained for this project. The first model is classification model. It takes two questions as input and basically classifies whether those two questions are duplicate or not. To train this model, first we have loaded the data using pandas. Then we have performed data cleaning. We have removed the stop words and we have used NLP to lemmatize the words. Lemmatization basically converts the total words into their base words. After cleaning the data, the next part is feature engineering. In feature engineering, first we need to convert the text into embedding. The first model which we have tried is sentence BERT. The specialty of this model is it is a Siamese twin network. It uses BERT. It uses two BERT models to take two questions as input, and it mean pools the output to find the sentence embedding, and it uses cosine similarity to find the similarity between those two embeddings. This improves the performance of the model. Apart from cosine similarity, we have also used Manhattan similarity and Euclidean similarity for this project. We have used distribution plot to check whether the particular feature is able to separate two class labels properly or not. For example, this plot represents cosine similarity from sentence BERT. There is some overlap, but it was able to separate many set of questions. But in sentence BERT, Manhattan distance and Euclidean distance did not work very well. Apart from sentence BERT, we have also used fast text. It is basically a model like word to vec, but it goes into n-gram level. It converts the words into n-grams. But after training this fast text model, we found that it was not able to separate the class labels properly. So we have skipped this model. Apart from SBERT and fast text, we have used universal sentence encoder. This model is from Google. The specialty of this model is it has been trained on multiple downstream tasks at a time, like skip thought, natural language inference, question answering, so that the embeddings provided by this model are much more powerful. As we can see here that it is able to separate duplicate questions from non-duplicate questions very well. There is very little overlap in cosine similarity of universal sentence encoders embeddings. Apart from embeddings, we also did some custom feature building, like common word count ratio, sorted fuzzy ratio, absolute lengths between two questions, character count ratio, character intersection over union. From those features, we have selected the best features which have separated the labels best. After generating all the features, we have normalized those features and we have split them into test and training datasets. As we can see from this PCA plot that the selected features could separate the duplicate from non-duplicate questions very well. There is very little overlap here. We first trained the XGBoost model with the extracted features, but the accuracy was not very good. So we trained a neural network model which had 2 layers. We have trained it for 50 epochs. After training for 50 epochs, we got a train accuracy and test accuracy around 90%. I'll further explain the model by testing with few examples in the front end. As you can see here, I have taken 2 questions as input. When I submit them to the model, it will predict whether those 2 questions are similar or not. It has predicted that these 2 questions are similar. I'll try with another set of questions. The model has predicted that these 2 questions are similar. As we can see that we are just talking about sigmoid function differentiation here. If I run the model with this example, it says that these 2 questions are different because one is asking about Java and another is asking about Python. I'll quickly go over the second model right now. The second model is semantic search. This model is basically like a search engine. It goes through the whole data set to find similar question with respect to the query question. To train this model, we got the sentence embeddings using universal sentence encoder, and we have placed all the sentence embeddings in a vector space. The embeddings for the questions which are similar will be closer in the latent space, and the embeddings for the questions which are not similar will be far away from each other. Later on, we have used Viviet to query over the latent space. Viviet is a low latency vector search engine which uses graph-based indexing so that it can quickly search the whole dataset. Viviet can typically search more than 1 million objects in less than 100 milliseconds. I'll quickly show how this model works from the front end. This model takes a question as input and it searches the whole dataset for similar questions. So it has taken the input from the user and it has written the most similar questions from the dataset. I'll try with one more example. The input question talks about Facebook API, and all the return questions also talk about Facebook API. The last part of our project is building the front end. We have built the front end using Streamlit and Plotly. And finally, we have packaged all our models front end and data using Docker, and we have deployed it to AWS so that it is highly scalable and continuously available